Embedded Controller Lab. We will discuss today how to interface LCD with ARM controller. So before that, let's discuss a few concepts regarding LCD. So your LCD, which we are using over here for this experiment, is having two lines. So 16 characters in each line it can display. So we are using 16 by 2 LCD display module. So 16 by 2 altogether we can print 32 characters together. So overall the pin out of your LCD module, it's having 16 pins. So out of which the most important pins which we will be using in your program happens to be 5 volt ground, uh, RS register select, uh, read or write, enable, and 8 data pins. I repeat, these are the pins which we'll be using. 8 data pins, 8 pins for transferring the data. 8 bit of data we are transferring. In Arduino, probably we might have used LCD header file. There 4 pins were used for transmitting data, which was addressed as D0, D1, D2 and D3. Over here 8 bit mode we are using, and that mode has to be addressed in the program. And along with that, control signals which we need to send it to the LCD module to make that understand whether we are transferring commands or data. So we will be using this command register. This is a control signal, register selector, and RW read or write data. And also to enable your LCD controller, we will be using enable line pin. And this should be something like we should provide a clock, then only the LCD module will enable and you can transfer a data. Fine. And analog LED plus this is anode LED plus, cathode LED plus, optional, but you can use it. Suppose if you're using LED module for the application wherein the lighting condition is very low, it's very dark background, then you can use this backlight LED could be triggered. Okay, so it requires external supply to be given so that more prominently you can display the information present in the LED module. That's for low lightning condition you can use, and this is for changing the contrast. The font information, if it's not looking good, you can try to increase it with the help of this. So we will not be using all this pin, so you cannot contrasts and all, you cannot adjust time being using this module. Already it is fixed. Fine. So the next block diagram shows the connection between your LCD module and your LPC microcontroller. So as discussed, 5 volt ground connected to the 5 volt and ground of your controller, and we will be using the control signals RS read or write enable lines. They are connected to port 115, port 116 and port 117. So in the program we will be using these pins belonging to port 1, port 115th pin, port 116th pin and port 117th pin. These lines are connected to register select, read write and enable. So suppose if you want to write a data onto this LCD unit, then you are supposed to make this line 0. Sending 0 here implies you can write into it. Suppose if you're transferring a data, or you can either send some commands. Commands are some of the signals which when you send it on to this LCD module, it might be used for the application wherein you may have to clear the screen, you may have to bring the cursor for the first line, you may have to take the cursor back to the second line. So for wearing the cursor for its position, for displaying or resetting, clearing the screen, for that you can use different commands, and we will discuss 4 commands which we'll be using in this program. And for sending commands separately or for sending data separately, this should this should understand whether you're sending commands or you're sending data. For that we will be using this line that will be used for differentiating. And this enable, we will be sending a clock pulse. It should be triggered high, then it should be made low for a while. So then only the LED LCD module will function. So clock needs to be given to make this LCD function. Fine. Then the pins starting from 18 to 25, don't read it as 52, it should be 25. I repeat, port 1 bits pins from 18 to 25 are connected to D0 to D7 of your LCD module. So you do not have to do any this kind of a connection. Already we have a module, LCD module in between. What you have to do is FRC2, you have a male connector and a female connector available, so connect accordingly, so you do not have to any of this connection as such. Hope this is clear. Okay, now let's look at the things about the addresses what you have in LCD. In LCD, first two lines, 16 by 2, 16 columns you have and 2 rows you have, so 16 by 2 matrices you have. Suppose if I want to print a character over here at the first line, first column, first line, first column, first row, first column, then its effective address is 80 at this location. This location has to be passed. This is a command which needs to be given to the controller, then only it will come to know at this location. This is a memory location, capacity is 8-bit. You can send some characters on this location, so that probably say that hello if I want to display, then H would be this is the position where H should get inserted, and H, we know that hex value of H, ASCII value of H is 48, and 48 will sit in this location 80. Okay, and similarly 81, so 80 to 8F altogether you have first line. Second row, C0 effective address. Second row, if you want to print some data, then remember C0 should be the data which you need to provide with, and CF till CF it goes. So altogether 32 characters you can print. And the main reason why we are using LCD rather than LED, 7-segment LED, is the characters whichever you want to print, probably special characters if you want to print it onto the line, Greek letters, Latin letters, so all those can be effectively transferred with the help of this kind of a module. Whereas if you're using LED, there is a restriction. For example, and all, with good resolution you cannot print it. And also each cell which we have here, each cell, its resolution is 5 by, it is not 8, we are using 5 by 7, 5 by 7, 5 rows, 5 columns and 8 rows. So that's the total number of pixels which you provide for displaying a character. So this is the resolution of each cell which you have here, each cell used for printing a character. So that's the pixel area which you are providing. So it's not 5 by 8, it should be 5 by 7. Okay, the program we will discuss now. Fine. So this program, we know this LCD device which we need to provide with string we are using. Even if it's not used, not at all a problem, I think it should be used. A string should be used because set of characters we are passing it as an argument to the command lcd_str. So string.header file indeed is required. And just remember some of the functions which we are using here. I'll just discuss that, then later we will look at how the flow goes. So init GPIO, here we need to configure the pins, which pins of the port we are using and what should be the value which we need to transfer in init GPIO. That's to set the direction. For the time being we will assume that init GPIO is used for setting the directional flag. Is it working as an input or is it working as an output port? That should be defined here. LCD string, it takes two arguments, the address, and in the address what data should sit, that you are indeed providing in the program. So this is the function declaration, it's not defined. Similarly, LCD data takes one argument. So data which you want to transfer, probably a character in this case, value, its ASCII value, how it is sent. So it should be unsigned int, because ASCII value is always a positive number. It is an unsigned number. It cannot take integer negative values. Similarly, commands which we pass to the controller, again that is also defined as an unsigned number. So you can either use unsigned character or you can use unsigned integer. It doesn't make any difference. Then we use void lcd int void. So this is for initializing your lcd module. So in this we will be passing the commands for initial configuration. For example, if you think that lcd is having some data content present in it, those information, if I want to clear it, when you're running LCD program for the first time, then you pass some commands, that is to clear the screen, and also the modes as I've discussed. Since we are using 16 by 2 LCD module here, even that should be addressed. How many lines? 2 lines. And how many characters? 16. For that there is a different command which should be passed, then only it will come to know that's you are using 16 by 2 mode. And also the pixel area which we have discussed, 5 by 7, that's the resolution provided for displaying each character, even that should be addressed. And also the number of bits you are using, 8-bit lines are used for transferring a data from the controller to the LCD module. Fine. So those will be defined in LCD init function. Okay, so this is your main program. So basically what we do here is we call first function init GPIO. Now let's discuss what happens when we call initialize general purpose input output function. So as soon as you invoke this function, the signal control flow goes to this line. So here we are using LPC GPIO1. So as discussed, the connections port 1 we are using, so we are supposed to use LPC GPIO1, and its directional flag we need to grab, and it should be set to 1 because we are sending some data. So all pins belonging to port 1, that is pin 1, port 1 0 to port 1 31, so altogether 32 pins, all are made high. So all are made high implies you're ensuring that through those pins you're sending some data. So this pins will be working as a output. Why output? Because we are sending some data to the LCD, so it has to be output. And LCD module is an output device. You send a data to those module, so this should be 1 always. So if made 0, then you can read a data from LCD. So reading data from LCD is also possible, but we will not discuss. For the time being, it is something like you're writing a data onto the module. So hope this is clear. Port 1, all pins are made 1. So all pins down the line from port 10 to port 131 I can use now. Hope this is fine. Then we call LCD init. So what is this LCD init? We will discuss. So LCD init, it goes to the function. This function will be called LCD init. So here what we have is 4 commands we are passing. LCD command 38. So remember, LCD command is another function wherein we will we will trigger the command line, like we have register select. There we will make command as enable, so that command we are passing. So here intention is we are not passing data, so we are passing command. Hence LCD command function is bit different than LCD data function. So control signals are different. Control signals are not same for LCD command and for LCD data. So first it takes this 38 address. Okay, 38 address, if it's applied, you can if you want to figure out what this 38 does, you can go to Google. In Google type LCD commands, so you can figure out there are nearly 20 commands, LCD commands, and all are having some functions. So it's something like in the controller, LCD controller, 16 by 2 controller, there is a memory address 38 wherein the service routine for this is written, which means it will configure that you're using 2 lines, 16 by 2 matrix it is, 8-bit mode, and pixel area is 5 by 7. So ensure that this is what the module is made for. So that's what this function does. Similarly, if you want to clear the content present in the LCD module, then this is the command which we need to use, 01. And 0C is to display, make the display on, and cursor will be off in this case. So literally we don't want cursor to be blinking always, so that can be switched off, turned off using this command. And 06 is to ensure that the character gets printed one after the another in the right direction. So shift the cursor after printing one character, go to the next location and shift the cursor, so cursor will be shifted. Okay, so you can check what happens if you provide this with 04. Any difference you figure out, that makes sense how it works. Okay, so this is what LCD init is. Now let's discuss. In turn, it calls the function LCD command. So LCD command program is addressed here. Fine. So first what we do is, let's assume that the argument taken by LCD command is 38. So 38 is the argument given, and this is the hex value. So what happens here? So here you have now 38 value, that is your hex value. Okay, and first what we do is, we shift the value 38 by 18 bits towards left. So why this is required? The reason is, when you look at the diagram here, port 1 18th to 25th bit we connected. Okay, so this is connected to data lines, and the register which we are using here, can have a look at what happens. So 38 we have data, and we shift the data 18 bits. When we shift the data 18 bits, it goes to the location uh, 18th to 25th location. This data gets passed, and the remaining location starting from 0 to 17 will be filled with 0. And this information should reach the register pin FIO pin register. In FIO pin register, we will be transferring a data, and this FIO pin register is having 32 bit. So what we do is, take the 18 take the data, that is 38, shift it by 18 bits, so it reaches the position. For if this is your FIO pin, it reaches the position 18, and 18 to 25 position is reserved for placing the data. So you cannot place the data anywhere in this FIO pin register. This is your FIO pin register, and FIO pin register of GPIO1 we are using. Okay, so we will be using LPC GPIO1, and there we take the register FIO pin, and there we need to shift the data by 18 bits, so it goes to the pins 18 to 25 is actually the space reserved for storing this data. Then the remaining bits starting from 0 to 17, they should also be filled with the corresponding value, because we have seen now this is for port 10, this is acting as port 131. So all are used for sending a data to through the ports. Okay, so 38, hope this is clear. So where you have 38, so this is the value 38, 18 to 25, this is your 38 shifted 18 bits. So that's what we get, and all others will be 0. Now how do you get this number? Let's discuss. So hope this is clear. So you shift the value is shifted, then we perform this OR operation. So we take a data 0002800, sorry, this is for command, sorry. So here you are with, so 0x302000, this should be ORed with LCD command. So LCD command, we know it is 38 data shifted with 18 bits. So from 18 to 25 you have a data, and other remaining bits will be set to 0. That complete 32 bit data is ORed with a data 2000 0. Why we select this data? So if I select the data as 2 followed with the 4 zeros, so what it literally does is you can just observe this is your 200 data. Okay, uh, where you have to show till this is 0, first 0, second 0, third 0, fourth 0, and you have 2 here. And this is 2, which means pin number 17 is 1 and all other pins are made 0. So doing that is nothing but, when you look at here, pin number 17 is made 1 and remaining bits are made 0. So it has to provide a pulse. It is to provide a pulse, and since we are using write, this is to write a data command has to be written onto the LCD module. So the status of enable should be made 1. After a while you should keep this state for a while. You have to provide a delay, then you have to trigger this low, so it becomes a falling edge of the clock. In that case the data will be transferred. And also we have selected WR pin, that is port 1 16th bit, this should be made 0 because we are writing something, and port 1 15th pin, this should be made as 0 because register select, if it's triggered as 0, it is saying that you're passing commands. If this is made 1, port 1 15th bit, then it means that you are passing data. Now when you observe this register content, port 1 15th bit is made 1, so implies that you are passing command, and port 1 16th bit is also made 0, which means you are writing a data, and port 1 17th bit is made 1, which means your this is your enable line. So you have 2, so 0 to 17 and remaining bits are all 0. That is odd with data which is having data beginning from 8 18 18 to 25, you concentrate, you have a data, and remaining values are made 0. When effectively you perform bitwise OR, this will be the ultimate result which you'll be getting in your FIO pin register, and this is the data which is sent to the LCD module. Hope this is clear. So what it does, it is to send the control signal. Along with the control signal, you will attach data together. This is the command information. Even this data is also attached to the control, attached along with the control signals, and you pass. Okay, and now this will not enable, because to enable you are supposed to provide a delay. Hence we are using a small delay. We hold this state for a while, then we make the pin number 15, that is pin number 17, that is enable pin, is made low. When this pin is made low, you get the information 0. Okay, so you have here 0. So with the 0 you pass the data now. So first this is for triggering the enable line high, and this is to trigger the enable line low, and this is the ultimate value of the control signal, and this is the data which you will be attaching. So data here 38 is shifted with 18 bits. Here again same thing. So now you have effectively sent a command. So this has to be repeated. So now this will come to know that at the starting address 38 in your LCD controller, there is a service routine which will ensure that the LCD module which you are using is 8-bit. It is in 8-bit mode, and it has a pixel area of 5 by 7, and also it will ensure that 2 lines are there. Okay, similarly the same function LCD command C, LCD command 1 and LCD 6 are passed. Hope this is clear. So it is used for initializing the LCD. So this does what? Nothing it does. It will clear the screen. Okay, and also all these modes are enabled now. Now next, what happens once you're down the line here, then we call the function while. Hope LCD init is clear. Then we are using while 1. Now repeat this process again and again. Now let's discuss what happens when we call LCD str. So LCD str function is here. LCD str function is here, and LCD str function takes 2 arguments. one is the address, and one more is actually the data which you are supposed to pass. So when you observe here, this is the address 80. That point onwards, hello should fall on the same line. After a while, clear the screen, delay, give a delay, then print welcome, then again give a delay, then print hello. So in the same line, hello welcome will be printed in this case. So what happens when you invoke the function lcd_str? So lcd_str function takes two arguments as discussed, and after that we define the count. So in the count, character count, we will set it is actually the index which needs to go from 0 to till the count length has reached. Fine. Length is used for holding the length of the string. Now we know that in the program hello we have, this is actually a string. So to access every element belonging to the string, we will be making use of a concept of a pointer. We will use a character pointer, and that character pointer will initially point to the first character of the string. H it will point. So to do that, you can just directly use star pointer, and that star pointer indeed is star message now. So if I am using now message, whole string you will get. Suppose if I'm using star message, then I'll be getting just H. I repeat, MSG has all information hello. Similarly, if I'm using just star MSB, that triggers just H. Okay, and we are supposed to grab H, not whole hello. So star message we are using, through the pointer one by one character we will access, and it will be displayed. Okay, so again in this case we will call lcd command address function. So lcd command address function we have already discussed. So here lcd command 0x80, 80 address we pass. That is to say that at that location the data what you have, one by one starting from 80 back to 81, 82, 83, 84, those locations store the value HELLO. Fine. Now we have length is equal to string length of message. So message I've told that gives you hello itself. So now the total characters present in hello is HELLO. 5 you have, the length is 5. So this loop repeats 5 times. So each repetition, so what you are doing is you use lcd data. Now you have the argument star message. Star message would give you the value H. So what is H? ASCII value of H is nothing but 48. So 48 is actually the hex value or ASCII value is the argument taken to LCD data. Now let's see how H gets printed using LCD data function. So LCD data function, when you call, so this program is getting function now. I just repeat, the job is you have to differentiate that are you sending data or are you sending commands, and for that we have a line port 115th pin, and that should be made high now. That is to ensure that you're sending data onto the LCD. Fine. So first job, you're having now the ASCII value which is 48, let us assume, and we use first value is equal to value shifted by 18 bits. So you stuff 17 0, then bit 18 to bit 25, hold the value, and that will be your effective value from 0 to 31th bit. Okay, I repeat, you have 48, shift it by 18 bits, hex value 48 shifted by 18 bits. So bit 18 to bit 25, the 48 information hex value 8 bits goes and sits in that location, and remaining bits will be set to 0, and that data is ORed with, bitwise ORed with data 280. Now the question is why 2800? Now let's go back here. This is your H48 value. So what do you have first? So you have 0100 where it is loaded from the point 18th bit. 18th bit you have here, 18th bit, and you can see 18 to 25th bit, you have that data, okay. And what happens, this has to be bitwise ORed with. So it has to be bitwise ORed with the data which is there here. So when you OR this data with this data, previous data, So here you can see this is actually 2800, 28, yeah, 2800. What is that? 2800. Bit number 15 is 1, bit number 17 is 1. So bit number 1, this has to be 1 because this is enable. You have to enable first, then give a delay, then make it low. So now enable pin is high, port 115 bit is also high, implies that your sending data. So if this was 0, then you're sending commands. So this is how the controller comes to understand whether you're sending data or commands. Hope this is clear. So this 2800 is odd with value. So this will be your content. This will be your content, effective content. So this data is passed, whole 32 bits are passed to the LCD module. So now you have effectively transferred the data H to the location 80, because command we have invoked earlier, at 80 location the data, that is H value, ASCII value of H goes and it gets set there. Okay, then you provide delay, then again after a while make this pin, 17th pin, low, enable pin, make high and low, falling edge of the clock, this gets enabled, LCD gets triggered. So we are supposed to make this low. So for that the command is 800 odd with value. Value is actually the data, this data shifted by 18 bits. Hope this is clear. So this will pass the data. Now you have H here, here you have H printed. Then what do you have to do? After that we require E. So message plus plus, message plus plus, then go back. Automatically the address will also be incremented because we have sent the starting address will also be incremented. We can think 81 is actually the location where you want E to go and reach. So what happens now? LCD underscore data star message, since we have incremented the pointer, now we have this as E. The ASCII value of E will be loaded and it must be 46 if I'm not wrong, 46 or 45, and that data would be over here and it gets shifted and it will be bit odd with this 2800. That is to say that this data you are sending effectively, give a delay and do this. So repeat this, so you'll get hello. Hope this is clear. And finally what we do here, we provide delay, then again call LCD str function, and here again on the same line welcome is printed, and finally you have a delay. Hope I have not left any function here. Delay function you can modify and you can see how it responds. Hope this is convenient for you. Fine, we will see this how to apply this for keyboard. So this can also be considered. Well, okay, that's what.